If you've ever talked to a voice assistant, you know the walkie-talkie problem. You speak, you stop, you wait for the machine to process, and then it speaks. This is called half-duplex communication, and it's fundamentally unnatural. The goal for the next generation of AI is full-duplex interaction, where the model can listen and speak simultaneously. This means the AI can handle conversational pauses, give a timely, as a back channel, or gracefully handle being interrupted by the user. But there is a massive technical hurdle here. When we try to train these models to handle the timing of a conversation using reinforcement learning, we often run into a catastrophic problem. The model forgets how to actually speak. Today, we're diving into a new framework called ASPIRin, which stands for Action Space Projection for Interactivity-Optimized Reinforcement Learning. It's designed specifically to solve the tension between when to speak and what to say in full-duplex speech-language models. To understand why ASPIRin is necessary, we first have to look at how we usually align these models. Normally, if you want to optimize a model's timing, you might use an algorithm like GRPO, Group Relative Policy Optimization. In a standard GRPO setup, the reward signal is applied directly to the fine-grained semantic tokens. The problem is that this forces the model to solve two completely different problems using the same optimization capacity: the temporal dynamics of the conversation and the linguistic coherence of the response. When the model chases rewards for lower latency or better turn-taking, it often hacks the reward. It becomes so aggressive about the timing that it loses its linguistic grounding. The result is generative collapse. The model starts falling into repetitive loops, producing meaningless engrams and completely breaking down semantically. ASPIRin solves this by introducing a concept called action space projection. Instead of optimizing the entire text vocabulary, ASPIRin decouples the timing from the content. It does this by projecting the vast vocabulary into a coarse-grained binary state: active speech versus inactive silence. Technically, this is achieved by partitioning the vocabulary into padding tokens and non-padding tokens. For any generated token, the model defines a binary action state. If it's a non-padding token, it's active. If it's padding, it's inactive. Now, instead of applying GRPO to the raw token policy, the researchers apply it to this projected binary policy. They calculate the state logits by summing the logits of all tokens within that binary category. This means the RL process is only teaching the model whether it should be speaking or silent at any given moment, without interfering with the specific words it chooses. To guide this, they use a rule-based reward system based on two main constraints: the interruption score and the response score. The interruption score penalizes the model if it speaks while the user is still active, ensuring it doesn't barge in. The response score encourages promptness, penalizing excessive latency between the user finishing and the model starting. By optimizing for the product of these two rewards, the model finds the sweet spot between being responsive and being respectful of the user's turn. So how does this actually perform? The researchers compared ASPIRin against a few baselines: a standard supervised fine-tuning approach, a standard GRPO approach, and a base Moshi model. The results are telling. Standard SFT actually degraded performance. It focused so much on the text that it ignored the timing entirely. Standard GRPO was the opposite. It was incredibly eager to interact, which improved latency, but it was far too aggressive, often talking over the user and, most importantly, suffering from severe generative collapse. In qualitative tests, standard GRPO produced responses that were essentially gibberish or repetitive loops. For example, when asked to change the topic to exercise, a GRPO-tuned model might just start repeating, "you know," over and over again. ASPIRin, however, maintained the semantic quality of the original base model while significantly improving the timing. It reduced n-gram repetition by over 50% compared to standard GRPO, and maintained a high semantic score from GPT-4o evaluators. If we look at the reward dynamics, the difference is clear. Standard GRPO shows massive instability and oscillations in its interruption scores. ASPIRin, because it's operating on a simplified binary action space, remains stable throughout training. It discovers that silence can actually be rewarding, which is the key to natural conversation. In short, ASPIRin proves that by isolating the decision to speak from the content of the speech, we can create AI that isn't just smart, but is actually pleasant to talk to in real time. Looking forward, the researchers suggest moving beyond a simple binary, speak or not state. Imagine a multi-class action space where the model can explicitly choose between a full response, a short backchannel like, or a listening state. This could lead to even more fluid, human-like interactions,